Hi, in this video I'm going to take you through how we go about actually solving problems relating to systems of equations. I'd like to acknowledge this problem comes from Jake Wills's NZ Maths site, and I'd like to thank him for the problem that he set up here. Right, let's have a look at this. We've got some people eating pizza. So Zoma, River and Bradley are eating pizzas. Zom eats 4 slices of pepperoni, 5 slices of spinach and feta, and 10 slices of Neapolitan. And he has 1,111 calories in total. River eats 5 slices of pepperoni, 6 slices of spinach and feta, 1 slice of Neapolitan, and 819 in total. Bradley eats 1 slice of pepperoni, 3 slices of spinach, and 3 slices of Neapolitan pizza. He ate 406 calories in total. And they summarize the information for you below them. The question is, how many calories in each slice of pizza? So, before we can go and start trying to solve this, we need to define our variables first of all. And you will see here in the question, we want to know how many calories there are in each slice of pizza. The number of calories that we got there. So our variables must be defined in terms of the number of calories. So we're going to say, let x equal the number of calories in a slice of pepperoni pizza. Pepperoni. Y is going to equal the number of calories in a slice of spinach and feta, and Z is the number of calories in a slice of Neapolitan. So now we've got our variables defined, we can now go and set up the equations. And this is where the table actually comes in quite useful, because our first equation is going to be Zoma's set of details over here. So we can say we've got 4x plus 5y plus 10z, and that comes to 1,111 rather. River has got 5x plus 6y plus z, and that comes to 819. And finally, Bradley had 1 slice of pepperoni, 3 slices of spinach and feta, and 3 slices of the Neapolitan, and he only had 406 calories. So here are 3 equations, A, B, and C, and we need to see if we can solve this. And to do that, we can either do it by algebraic method, or we can use it on our calculators. So I'm going to do the calculation bit first, and then we're going to come and look at the algebraic part. So we get the calculator out, clear out. Well, let's just make sure we know how to get to that. So you'll go to your equation section on the calculator. We want to clear out any information we may have in the table, so we just delete all of that. They want to know how many variables we're going to use, so we're going to use 3 variables, and there is our table. And it's set up in the right format to match the equations. And now all I have to do is to go and put in the coefficients, the numbers that come in front of the x, the y, and the z. So this is going to be 4x plus 5y plus 10z, and that comes to 1,011. Then I've got 5x and 6y and 1z, and that comes to 819. And finally, I've got an x plus 3y plus 3z, and that comes to 406. Press that, and we get it now asks us whether we want to solve it, so we press F1 to get solve, and there we've got it 66 for x, 77 for y, and 37 for for z. So x equals, I've forgotten it now, 64, 77. Okay, 64, y equals 77, and what was the last bit? 37. And z equals 37. Now, we don't just leave it there, because the question is set in a context, and the context is how many calories are there in each slice. So therefore we can say a slice of pepperoni has 64 calories. A slice of spinach and feta has 77 calories, and a slice of Neapolitan has 37 calories. Now, it is crucial that you put that down at the end. You've got to make sure that your answer makes sense in terms of the context of the question. So you have to have that part there. That is essential. So here are the 3 bits that you need to do. You need to define your variables, you need to set up a set of equations, and you need to solve it and give an answer in context of the question. If you can do that, then you're on the way to getting an achieved. Right, that is only easy if you have a graphics calculator. If you don't have a graphics calculator, you're going to have to do this through algebra. So let's take a look at how we go about doing that. There are the 3 equations, and we need to decide what we're going to eliminate. We're going to have to eliminate one of the variables, x, y, z. Because the numbers in front of them are smallest with the x's, I'm going to eliminate the x's. So, to begin with, let's say we're going to have 5c minus b. So 5c, 5 times everything in the c row, that's going to give me 5x plus 15y plus 15z, take away equals 2030. And minus b means everything in the b line is going to become negative, so it's become minus 5x minus 6y minus z equals minus 819. And when I join those 2 together, I'll get 9y plus 14z equals 2030, take away 819, and that gives me 1211. Now I'm now going to have to work with equations A and C, so I'm going to have 4 lots of C take away A. I'm going to be able to see it over there if I do it in that space. So 4C take away A. 4C is just going to be C times everything's times by 4, so it'll be 4x plus 12y plus 12z equals 406 times 4 gives me 1624. And take away a, so it's going to be minus x, 4x minus 5y minus 10z equals 1011. And if I add those 2 lines together now, the x's go, I'll be left with 7y plus 2z equals 1624 minus 1011, and that gives me 613. So here are the 2 equations that I need to work with. That equation, which I'm going to call equation D, and this equation here, which I'm going to call equation E. I now have 2 equations with 2 unknowns. Do I have space there? Yeah, I do. So let's try and work with this. I think the easiest thing to get rid of now will be the z's. So I'm going to say equation D minus 7e. So, no, go away. Equation D is 9y plus 14z equals 1211, and 7 lots of e is going to be, or minus 7 lots of e is going to be minus 49y minus 14z equals 613 times 7 gives me minus 4291. And if I take away 1211 from that, I'm going to be left with, here I'm going to have minus 3080 is equal to minus 40y. And if I divide both sides by 40, I'm going to get that y is equal to 77. So that's a bit of hard yakka to be able to get all of that through. If I go and sub y is equal to 77 into, which is going to be the easiest one, into e, then I'm going to get 7 times 77 plus 2z is equal to 613. 77 times 7 is 539. So 2z is going to be 613 minus 539. So 2z is going to equal minus 74, and so z is going to equal 37. So not minus 74, it's plus 74. And I think you should be able to see now that we've got our y value, we've got our z value, and they're matched up with the ones that we had over there. And now, in order to get what my x value is going to be, I need to substitute those two values, x and y, into an equation. I'm going to take equation C. So sub y is equal to 77, and z is equal to, what do we say it was? 37. 37 into equation C, and you're going to get, there's equation C over here. I'm going to get x minus, plus 3 lots of 77 plus 3 lots of 37, and that's going to come to 406. And so what have we got here? 3 times 77, that's 231. 3 times 37, it's going to give me 111. And so finally I'm going to be able to say x is going to equal 406 minus 342, and that's going to give me 406 minus 342, that's going to give me 64. Hopefully 64 was the x value. Yes, it was. So that's the way in which we can get it without a graphics calculator. And I won't pull any punches about it. Yes, that is difficult. That is tricky, especially as you chose to do this course because your algebra is not great. This is the way in which you'd have to tackle it. So get a graphics calculator. Next video, we're going to look at the second part of the problem. See you then. Goodbye.